There are several different ways to solve quadratic equations. So today we're going to talk about solving quadratic equations by factoring. The first thing you need to do is you need to go back and you need to practice factoring. So pause the video and factor these. All right, this is what you should have gotten. Okay, there's that one factored. There's this one factored. Didn't know if it was top or bottom. There's that one factored and that one factored. Don't forget that the first thing you always do when you factor is you take out the GCF. If you had trouble with these, go back and watch the video on factoring. All right, the zero product property is very simple. Basically, it says if you have two things that are multiplied together, this times this, and it equals 0, then one of these spots has to be filled with a 0. All right, so when I have something written like this in factored form, and these two binomials multiply together to give you 0, then one of those binomials has to equal 0. So it's either this one, and if you were to set it up, x minus 7 equals 0, then x would have to equal 7 to make that happen. There's one possible answer. Or it could be this one, in which case x plus 2 would be the part that equaled 0, and x would have to equal negative 2. Okay, so what you might want to do is pause the video and take a look at the ones that I have written here and see if you can figure those out. All right, if this is the part that equals 0, then x would have to equal 0. If this is the part that equals 0, x would have to equal negative 2. This one's more difficult. So what I did is I took the 2x plus 3, set it equal to 0, subtracted 3 from both sides, divide both sides by 2. X could equal negative 3 halves, and that would make this one equal to 0. Did the same thing over here. Took the 4x minus 7 is equal to 0, added 7 to both sides, divided by 4. X is equal to 7/4. Now, there is a trick to this. If you look very closely, the opposite of this value divided by the coefficient. Okay, little trick there. All right, let's keep going. All right, to solve by factor, the first thing you have to do is make sure that your equation is equal to 0. It doesn't work if you have two factored things that multiply together to give you 7 or 20 or whatever. It has to equal 0. That's how come we can use the zero product property. So you need to set the equation equal to 0. You need to factor the polynomial that you have, and then set each one of the factors equal to 0 and solve. Now, sometimes it's very simple. This can also get very complex. So let's try that. Let's try those steps. It's already set equal to 0. So now we're going to factor this. Now again, to factor this, go back and look at the factoring videos. But this one is going to be x minus 4. X minus 2 is equal to 0. Therefore, the values for x that will work would be a positive 4 and a positive 2. Now you see this little note here that says you can check by graphing. This is already set up beautifully for graphing. We're just going to replace the 0 with a y. On your graphing calculator, just put in the equation that was set equal to 0 and graph it. And what are the values here? Well, that looks like a 2 and that looks like a 4. Now remember, we can actually ask this to help us by going to menu. We can go to Analyze Graph, and we're looking for the zeros. So if I start here, my first 0 is right there at 2, 0. My second 0, is it going to let me do it? No, we'll stop there. Because there's a 0 right there at 2, 0. Let's do it again. Menu, Analyze Graph, zeros. Let's start here, come across here. There's the second one at 4, 0. So that's a real quick, easy way to check. Pause the video and try these three first. Okay, remember you have to set it equal to 0 first, then factor, and then solve. So for the first one, I subtracted 21 from both sides to make it equal to 0. I factored it. The value that will go in here to make this equal to 0 is negative 7. the value that will go in here to make this part equal to 0 is 3. This one's already set equal to 0. I recognize this as a perfect squared trinomial, which can be factored as x minus 6 squared. Since this is really x minus 6 times x minus 6, they're both exactly the same. So the only value that will work in here to make this equal to 0 is a 6. Again, if you were to check this by graphing, you would expect to see a parabola that touches the x-axis only at the vertex. This last one was a little trickier. I added 2x squared to both sides. I never like to have a leading coefficient that's negative, if at all possible. So I had the 0 over on the left-hand side. It really doesn't make a difference. First thing I need to do is take out a GCF, which is 2. Once I do this, I recognize this as a perfect squared trinomial, and that is factored x plus 5. The only value that will go in here to make this equal to 0 is negative 5. Okay? Here's some more to try. All right, for the top one, again, I recognize right away that this is a perfect square trinomial. That must be important that we be able to recognize that. Anyway, it's factored x minus 3 squared. The value that will go into here would be 3. For this next one, again, I made it so that the leading coefficient was positive. I added 9x squared to both sides, added 25. Okay, again, this is a perfect square trinomial, which is factored 3x plus 5 parentheses squared. Okay, remember the trick is the opposite of this, which is negative 5, divided by the coefficient in front, and there's the value that would make that equal to 0. And that's it.